Ionic compounds are made up of negatively charged nonmetal atoms, anions, and positively charged metal atoms, cations. What holds these compounds together and makes them an actual compound is that the positive and the negative charges attract one another so that the two ions come together and form a compound. However, the actual structure of an ionic compound is not quite so simple. It is actually made up of a large number of positive ions and a large number of negative ions, all put together into what is called a lattice. That's what we're going to discover in this video. Let's begin by thinking about sodium chloride, which we know forms a 1-to-1, 1 sodium to 1 chlorine compound because sodium is in group 1 and therefore forms +1 cations, and chlorine is in group 17 and therefore forms -1 anions. So we need 1 sodium and 1 chlorine to make a neutral compound. This is the way we symbolize sodium chloride as a compound. If we zoom down to the microscopic level, we can see that the actual compound is made up of a whole bunch of chlorine anions and a whole bunch of sodium cations in an alternating pattern called a lattice. This type of lattice structure is common to all ionic compounds. This particular lattice alternates in such a way that there will be the same number of sodium atoms as there are chlorine atoms. I can tell that this is true if I count the number of chlorine atoms that surround each sodium atom. So if I look at this sodium atom, I can see that there are 6 chlorine atoms around that sodium atom. So 1, 2, 3, 4. There's one in back in the middle of the lattice, that's 5. If the lattice extends out in this direction, there's going to be another chlorine atom right here to make 6. So each sodium is surrounded by 6 chlorines. If I look at one of the chlorines and count the number of sodiums around this chlorine, I see 1, 2, 3, 4. And then if the lattice extends in this direction and this direction, there'll be a sodium atom right here and a sodium right here for 2 more, making 6. 1, 2, 3, 4, 5, 6. So every chlorine is surrounded by 6 sodiums. If each chlorine and each sodium are surrounded by the same number of the opposite charged ion, then there must be the same number of sodiums and the same number of chlorines in this structure. In contrast, let's look at potassium sulfide. Potassium sulfide forms a 2-to-1 complex because potassium is in group 1 and therefore makes +1 cations, and sulfur is in group 16 and so it makes -2 anions. So I will need 2 potassiums for every 1 sulfur to make the neutral compound. On the microscopic level, that looks like this. Again, we have positive potassium cations surrounded by negative sulfur anions in an alternating fashion to form a lattice. This lattice structure, again, is common to all ionic compounds. But in this case, if I count the number of purple potassiums around each yellow sulfur, I will count 1, 2, 3, 4, and then if the lattice extends in this direction, 5, 6, 7, 8 on the front face of this sulfur. So 8 potassiums around each sulfur. However, if I look at a potassium and count the number of sulfur atoms around that potassium, let's look at this one, I will have 1, 2, 3, 4 sulfurs around this potassium. So the potassium ion has 4 sulfur atoms around it, whereas the sulfur anion has 8 potassium ions around it. That's a ratio of 2 to 1, and so my compound is a 2-to-1 compound. It's important to note that when we have ionic compounds, the symbol that we use does not represent the total number of sodiums or the total number of chlorines in my compound, but rather represents the ratio of sodium to chlorine or the ratio of potassium to sulfur. The total number of sodiums or the total number of chlorine ions in my compound will depend on how much of that compound I take. If I take a really, really big crystal, I'm going to have a lot of sodiums and a lot of chlorines. If I take a really tiny little crystal of the sodium chloride, then I'm going to have less chlorines and less sodiums. So to represent this compound, because it's the same whether I take a large crystal or a small crystal, I'm going to use the smallest whole number ratio, or the ratio between sodium and chlorine atoms, to symbolize this compound.